Okay, in this video, I'm going to go ahead and solve this problem. I made another video of how to solve it using one coordinate system. I'm going to change my coordinate system and solve this a different way. So a ball's being thrown up with 30 meters per second from a cliff 50 meters above this ground. I'm going to go ahead and point out a few things that I might not have pointed out before. First, when you throw up a ball, let's say right here, let's say I launch a ball up at 30 meters per second. What's going to happen is this thing might be going fast. I'll go like this. And right here, it will be going at a velocity of 0, right? It'll slow down, because acceleration is about negative 10 meters per second if I call up positive. So eventually, like after 3 seconds, essentially, after 3 seconds, it'll stop and then it'll start accelerating downwards, right? And so what happens here, the whole time for this thing to go up and down would be about 6 seconds. That's what we're looking at. Now, it turns out that the first half of this time is 3 seconds, and it's the same amount of time that it takes to go down here. So 3 seconds up and 3 seconds down. And after 3 seconds coming down, right at the same point, this thing's actually going down 30 meters per second, or like negative 30. I hope that makes sense. And I'm going to take advantage of that when I'm going to solve this problem. So I'm going to go ahead and draw this out. Okay, a ball being thrown up this way at 30 meters per second. It's going to do something like that. This is 50 meters. Okay, once again, I'm going to define my coordinate system. I'm going to call this x naught. But this time, I'm going to call my final position up here x. And I'm going to go ahead and define my coordinate system. I'm going to say this is my 0 point, 0, and up is positive. But I'm only going to look at this section here. Okay, so I'm going to call that my final position. And up here, I know that my final velocity will be 0. Remember, if I throw it up at the top of its, what they call an apogee, or the top of its trajectory, the final velocity will be 0. It'll go up, we'll stop for a second, and it'll speed up. So right here, I know that my final velocity up here is going to be 0. So I'm going to go in far and say that that's 0 up there. This is my initial velocity. Okay, given. What do I know? I know that my initial position is 0. I don't know my final position, but I know my final velocity is 0. I know acceleration, let me define acceleration, is negative 10 meters per second squared, because I'm calling it positive. And I know my initial velocity is 30 meters per second. Unknown. There's a few things that I need to know. What I'm really looking for is how far up did it climb. So really what I want to know is my x. Or I could also find my time. But for this one, what I really want to look for, is my time, it turns out. Sorry about that. Yeah, I want to find out how much time it going up here. About 3 seconds. Oh, smokes. All right, hold on. Try that again. Okay. So I'm going to go ahead and look at my equation sheet. So I need something that's going to relate my final position, my final velocity and acceleration, my v naught, my initial velocity, and I'm looking for my time, and that one's kind of like the big glaring one. And even if you think about it, you can already kind of tell it's going to be 3 seconds, but I'm going to formally do this. So the equation I'm going to use is going to be v is equal to v naught plus at. And my final velocity is 0. My initial velocity is 30. My acceleration is -10 times t. And then, you can go ahead and find out that t is equal to 3 seconds. Okay, so it took 3 seconds to go up here. Now what I can find is that x. All right, so that's what I'm going to go and do. I'm going to go and find my x now that I know my time. It seems like a little bit more steps, but it's up to you. I mean, this is physics. That's how it goes. So now I know my time, and I'm going to go ahead and say I want to know how far up it climbed. So now I'm going to go ahead and my initial position is 0. My initial velocity is 30 meters per second. I don't know my final position. I know my time this time now is 3 seconds. And I know that my final velocity is 0. And I know my acceleration is -10 meters per second squared. Okay. My unknown is that final x. And once again, I'm going to look at my equation sheet. And I'm going to notice that I'm looking for that final x. That one solves for it. So I'm going to use that one. So x is equal to x naught plus v naught t plus 1/2 at squared. I'm going to plug everything in. I don't know my x. 0 plus my initial velocity is 30 meters per second times my time, which is 3 seconds. 1 plus 1/2 times -10 times my time squared. Okay, 0 goes away. We have 90. -5 from this is -5 times 9. 3 squared is 9. And then it's going to be -45. So x is, what's that, 45? Okay, so what do we find? We found that from here to the top is 45 meters. Now keep in mind the big picture. What is the question asking us to find? It's asking us to find how long did it take for the ball to hit the ground. So we already found that this thing took 3 seconds to climb. Now we have to find out how much time it took to fall. So just kind of remember that. It's 3 seconds. To fall, now we're going to kind of change our problem a little bit. Now we're going to look at a problem where this thing starts up here, where we're going to call that initial velocity 0. Because remember, it's going to go up, it's going to stop for a second, and then it's going to fall, and then we have a final velocity here. But we need to know the time. And this thing's going to start falling and accelerating. And now we know how far it fell because we just found that from here to here is 45 meters. And so the total distance this thing's going to be climbing is 95. So now we're going to change our problem slightly to a point from it goes from here to the bottom 95 meters. And we want to know how long it took to do that. And we know, once again, we can define our coordinate system. Just to make things easy, I'm going to call down positive this time, because now that's going to make my acceleration positive 10 meters per second squared. And I'm looking for my time. So given, what do I know? I know my overall final position. If I call this part x0, and this is going to be my final position, I know my final position is 95 meters. My initial position, I'm going to call 0. I'm going to call this my new 0. My initial velocity is 0. I don't know my final velocity is one of the things I want to find, but first I need to find that time. Okay. And that's acceleration is, since I'm calling down positive now, my acceleration is positive, which is, by convention, I'm just choosing down to be positive. Makes things easier. Okay. So what am I looking for? I'm looking for time. I got all this other stuff. And let's go ahead and look at our equation sheet. And sure enough, there's a few of them we can use. It's really going to be one of these two. We know our initial velocity, but we don't know our final velocity yet. We can get that soon enough. Because if we know the time, then we can figure out, the time it takes the fall, plug that in, you know your acceleration, your initial velocity 0, your final velocity. That's how you do the second problem. But I'm looking for the time it took for it to fall. So it's going to be this one here. And so I'm going to go ahead and write that equation down. X is equal to x naught plus v naught t plus 1/2 at squared. And then we're going to start substituting in. We know our final position is 95. We called that nu 1. This is my nu 0. So it's going to be 0 plus our initial velocity is 0. Our time we don't know. So we're going to leave it as a variable plus 1/2. We choose down as positive, so that's going to be positive 10. And then once again, we don't know our time. And so now a lot of stuff starts canceling out. This goes bye-bye, that goes bye-bye, and I have 1/2 of 10, which is 5, t squared. I'm going to solve that by dividing both sides by 5. T squared is equal to, what's that, 19? I get the square root of both sides. And hopefully, if I did that right, we're going to get the same answer that we got last time. You can prove it to yourself that when you do the square root of 19, you get t is equal to 4.35. So what does that mean? Seconds. That means we found that the first part of this from here to here took 3 seconds. And from the top of the trajectory to the bottom took 4.35 seconds. So our total time, I'm going to call it t total, is equal to our, zoom out here. There you go. Our total time is the 3 seconds it took to climb up here. There you go. Is 3 seconds plus the 4.35 seconds it took to fall. So 3 seconds plus 4.35 seconds. And what you get is your total time. 7.35 seconds, which is pretty much the same answer we got from the other method. Okay, and then you can, to do the second part, we can go ahead and plug that in to this other equation if you want to find out your final velocity. Now we know our total time, we know our acceleration, we know our initial velocity, and then we can find our final velocity. We want to find out how fast it's going there. And I hope that helps. Okay.